In this video, we want to learn how we can find average value of a function over a region. Here the function is xy, so we want to find the average value of the function xy over a triangle that its vertices are 0, 0, 1, 0, and 1, 3. Let me remind you the formula for average value of a function over a region. Average value of function f, for example, over a region is 1 over area of that region. So 1 over area of, in this case, area of this triangle, 1 over area of the region times by double integral of the function, whatever the function is, over the region. So average value is 1 over area of this triangle, in this case, times by double integral of the function, which is xy, over this triangle. The first thing that we have to do is to draw the triangle, because we need to know the area of the triangle and we have to find the double integral of the function over this triangle. So let me draw the triangle here. The triangle has 3 vertices. One is at 0, 0, the other one is at 1, 0. So let's suppose here is 1, 1, 0, and the other point is, the other vertices is 1, 3. So 1, 2, 3. Let's suppose 3 is here for y. So this is the other vertices. And this is our triangle. This region is the triangle. It should be clear for you that the equation of this line, this side of the triangle, this point is 0, 0, this point is 1, 3. So the equation of this line is y equals 3x. So y equals 3x. Because we need to know the equation of that line to write the region for our double integral. So we need to know the equation of that side. The first thing that we need to find for finding average value of a function is area of the region. This is a simple area. This is a triangle. So we can use the formula for area of a triangle to find the area. So area of this region, area of this triangle is 1/2 times base times height. This is 90 degrees, so this is our base. The base is 1. The height is 3, so this is 3 units, so times by 3. So the area of the region is 3 over 2. 3 times 1 times 1/2 is 3 over 2. Now that we have the area of the region, we have to find the double integral of this function over this region. But before that, let me tell you how we can find the area of the region if it was not something like this, a triangle. Sometimes we have more complicated regions, and in those cases we don't have a formula to use that formula for finding the area of that region. For finding the area, we know that one of the applications of double integrals is finding the area of regions. But to find area of a region, the function that you have to write for inside the double integral is 1. Whenever we are finding double integral of 1 dA over a region, let's say that region is D, this gives you the area of that region. So this is something that is good to know. Whenever the function that is here, that we are finding its double integral is 1, double integral of 1 would give you the area of the region. So let me show you how this works in this case. So for finding the area of this triangle, we have to find the double integral of 1 dA. Now we have to write the lower limits and upper limits for our integral. For dA, you can use dx dy or dy dx. And the order really doesn't matter because it's a very simple function. We have one only. So we can, let me write, for example, in this case, dy dx. By looking at this triangle, you can see that the y, if you draw vertical vectors like this, you can see that y starts from 0. This line is y equals 0. So the lower bound for y is 0. And the upper bound, please attention, let me draw again this. As you can see, this vector enters the region at this line and exits or leaves the region at this point. But what is this point? This point lies on this equation. So the upper bound for y is 3x. So y is changing from 0 to 3x. So here is 3x. What about x? For x, simply by looking at this triangle, you can see that the smallest amount of x is 0 and the maximum value for x is 1. So x is changing from 0 to 1. Now we have to integrate 1 dy. Integral of 1 dy is y. So we have integral 0 to 1 of y, which is changing from 0 to 3x. Integral of 1 dy is y. Y is from 0 to 3x. If we plug in 3x for y, we have 3x. If we plug in 0, it's 0. So this integral equals integral from 0 to 1 of 3x dx. But integral of 3x is 3x to the 2 with the power rule. This integral is 3x to the 2 over 2 from 0 to 1. If we plug in 1, it is 3 over 2. This value is exactly the value that we got from the formula for area of the triangle. But of course, this method is useful for not cases simple like this. Whenever this region is something that you don't know the formula for finding the area, you can use this method for finding area of the region. Now let me erase this because we don't need this. Already we have the area of the region. Now we have to find the double integral of the given function, which is xy, over the region. Now we have to find basically the double integral of xy over region d dA. Because again, this is very simple function. The order of integration doesn't matter. You can write dx dy or dy dx. So I am going to choose dy dx. Y is changing again from 0 to this line. So y is changing from 0 to 3x. And x is changing from 0 to 1. Now we have to find this double integral. Integral of function xy with respect to y is xy to the 2 over 2 from 0 to 3x. Attention, we integrate with respect to y, so x is a constant. We write the constant and integral y is y to the 2 over 2. Now we have to substitute 3x. And I forgot to write dx here. So if we substitute 3x inside this, we have integral 0 to 1 of x times 3x to the power of 2 is 9x to the 2 over 2. So 9x to the 2 over 2 dx. If we substitute 0, it's 0. For finding this integral, 9 over 2 is a constant, so we move the constant to the outside, and then we have integral from 0 to 1. X times x to the 2 is x to the 3 dx. Integral of x to the 3 is based on the power rule is x to the 4 over 4 from 0 to 1. If we plug in 1, we have 1/4 times 9 over 2, which is 9 over 8. If we plug in 0, it's 0. So 9 over 8 is the value of this double integral. And the area is 3 over 2. So the average value of this function is, so the average value of the function, let me write it here. So the average value equals 1 over 3 over 2 times by 9 over 8. 1 over 3 over 2 is 2 over 3. We flip the denominator and we move it to the numerator, so it's 2 over 3. If we simplify this, 3 with 9 simplifies 3, 8 with 2, this would be 1, here is 4, so we have 3 over 4. So the average value of this function over this triangle is 3 over 4. Now let me show you another example so we understand this topic better. Find the average value of the function x cosine y over this region, which is bounded by these curves y equals x to the 2, y equals 0, and x equals 1. Let me draw this region here first, because we need the region. Y equals x to the 2 is this curve. Of course, it extends here, but we don't need that part. Y equals x to the 2 is this. Y equals 0 is this. Is the x-axis basically, and x equal 1, let's suppose 1 is here, so here is x equal 1. So this is our region. Now we want to find the average value of the function f. So f average, whatever notation you want to use, f average equals 1 over area of the region times double integral of the function f over that region. First, we have to find the area of this region. And attention, this is not a triangle anymore. So, for finding area of that region, you can use double integral or you can use single integral. But here, because the topic is about double integrals, I prefer to use double integral method for finding the area. And as I mentioned, the area equals double integral of the function 1 dA over the region. So we want to find double integral of function 1, and again for order of integration I prefer to choose dy dx. If you attention, y starts from 0, and if we draw vertical lines like this, it enters the region here and it leaves the region or exits the region at this, which is x to the 2. So y is changing from 0 to x to the 2, and x is here from 0 to 1, so 0 to 1. Now we have to find the double integral. Integral of dy is y. So this equals integral 0 to 1 of dy is y. We plug in x to the 2 for y, so we have only x to the 2 dx. Integral of x to the 2 is x to the 3 over 3, 0 to 1, so the answer is 1/3. So area of this region here is 1/3. Attention, if you want to use single integral for finding the area of this region, because this function is x to the 2, so you have to integrate x to the 2 from 0 to 1, which would be exactly this, and you will get the same answer. So it doesn't matter to use double integral method or single integral method for finding the area. The other thing that we have to find is the double integral of the function x cosine y over this region. So we have to find double integral of the function x cosine y dA over region D. So this equals integral 0 to 1 integral 0 to x to the 2 of the function x cosine y dy dx. Integral of x cosine y dy dx. For finding this, we have to find integral of cosine y with respect to y first. We have to find the inner integral. Integral of cosine is sine, so this equals integral 0 to 1. So this equals integral 0 to 1 x. Integral of cosine is sine y from 0 to x to the 2 dx. If we substitute x to the 2 for y, then we have integral 0 to 1 x sine of x to the 2 dx. If we plug in 0 for y, sine of 0 is 0, so everything is 0, so we don't need to substitute 0. Now for finding this integral of x sine of x to the 2 dx, we want to integrate this with respect to x. If we use a simple u substitution, we can find this integral. This integral equals, with a u substitution, this integral equals 1/2 negative 1/2 cosine of x to the 2 from 0 to 1. Integral of sine is negative cosine, and this integral with a simple u substitution is this. I will show you after I finish my calculation here why the integral of x sine of x to the 2 dx is negative 1/2 cosine x to the 2. But for now, suppose this is the answer. Now we have to plug in 1, we have to plug in 0, and we have to subtract these two from each other. So we have negative 1/2 cosine 1. If we substitute 1 for x, we have this minus this expression. When we substitute 0, minus would be plus, so plus 1/2 cosine of 0. Cosine of 0 is 1, so this integral equals, finally at the end is negative 1/2 cosine of 1 plus 1/2. Cosine of 0 is 1, so this equals this. And I prefer to write this answer in the form of, if I factor a 1/2 from these two, we have 1/2 times 1 minus cosine 1. So this is the value of the double integral. The value of this integral is 1/2 1 minus cosine 1, and the area is 1/3. So what is the average at the end? The average equals, so this equals, let me finish my solution here. So this equals 1 over 1/3 times by the integral. What was the integral? 1/2 1 minus cosine 1 times by 1/2 times by 1 minus cosine of 1. 1 over 1/3 is 3. So this is 3. 3 times 1/2 is 3 over 2. So the average is 3 over 2 times by 1 minus cosine 1. But before I finish this video, let me show you how we can find this integral. Why the answer of integral of x sine of x to the 2 is negative 1/2 cosine of x to the 2. For finding this integral, for finding integral of x sine of x to the 2 dx, we can use a simple u substitution. If we suppose u as x to the 2, then du is 2x dx, and if we solve this for dx, dx is du over 2x. Now we do the substitution. Leave x and sine of x to the 2, because x to the 2 is u, it is sine of u, and dx is du over 2x. The x with x cancels, and these two we can move it to the outside of the integral, and we can write this as 1/2. So because it's in the denominator, so this equals 1/2 integral of sine of u du. Integral of sine is negative cosine, so this equals negative 1/2 cosine of u. But what is u originally? U is x to the 2, so negative 1/2 x to the 2 plus c. This is the answer that I used for my finding the integral. I hope by watching this video you have learned how to find the average value of two variable functions over general regions. If you like this video, please subscribe in my channel, and see you in the next videos.